Hi, my name is Lewis McCaffrey, and I am a research scientist with the Division of Water at the New York State Department of Environmental Conservation. So I'm going to be talking today about harmful algae bloom, or HAB, monitoring and lake evaluation methodology in New York State using Sentinel-2 data. My co-authors Sarah Rickard and Brian Duffy are from the same division as me, and Sarah Akbarnejad-Nacheli is from the State University of New York Environmental Science and Forestry College. The outline of my talk, I'm going to cover how we monitor lakes at the moment and how we monitor harmful algae blooms. I'm going to get into estimating water quality parameters using satellites, and then I'm going to talk in a bit of detail about how we have tried to verify the models that we arrived at and how we validated them. Do they really pass the sniff test? So we're going from a molecular level here, the phycocyanin molecule, to individual colonies, up to harmful algae blooms, and then all the way up to the scale of the state. So our previous sampling, which has used citizen scientists in the Citizen Science Lake Assessment Program and professional DEC staff, has seemed to focus on larger and more eutrophic lakes, and we have not sampled as much as probability would suggest in the smaller and medium-sized lakes on this graph. New York, like the rest of the US states, are required to put together lists of regulated lakes in 305B lists, and those lakes that are impaired for their best uses, amongst which is total phosphorus. At the moment, total phosphorus requires water quality samples to verify impairment, but we and various people have been looking at pigments, Chlorophyll-a and the cyanobacterial pigment Phycocyanin, to see if we could provide supplemental indicators for the 303D impaired lakes list. Could we use harmful algae bloom reports as an indicator? Well, Chlorophyll-a has a relatively good correlation with total phosphorus. Its coefficient is R squared is 0.74, and anything above 0.5 would be considered a relatively good correlation. Phycocyanin, on the other hand, has a relatively poorer R squared. My colleague Rebecca Gorney, who's now at the USGS, investigated the reports of harmful algae blooms that were put into DEC, New York State Department of Environmental Conservation, between 2012 and 2020. And amongst other interesting findings, she highlighted the need for more unbiased and representative HAB monitoring and evaluation methods. One of the challenges of this project is that HAB monitoring is quite complex. HABs are spatially variable, they're patchy, and have it's difficult to tell the size of a bloom based on your observation from a shoreline in a large lake. We know that HABs are temporally variable, and it's difficult to determine whether a HAB report is representative of conditions across a whole lake. We do think that there's observation bias. For instance, frequently visited lakes have more reports, higher profile lakes have more reports, and lakes in densely populated areas are likely to have more eyeballs on them. Conversely, we would expect lakes in remote areas that are less visited and, for instance, that have lower cell phone reception to have fewer reports. And so there's a clear need for approaches favoring representative lake characterization. Satellite observations, we think, may be a solution. So why use satellites for HAB reporting and lake evaluation? Well, using the right satellite system, there are thousands of lakes resolvable across our state. There are data sets going back several years, and in fact several decades. Landsat goes back to 1970s. There's good levels of confidence, and the detection limit is quite low. The imagery is free, and those systems are ongoing, and there's a low lag time. But there are significant downsides to satellites. There are lots of clouds, and they obscure the lakes. Even the cloud shadows complicate matters. Dealing with satellite imagery can be a little bit complicated. The detection limit, we think, is around the eutrophic boundary. For New York State, that's 8 micrograms per liter chlorophyll-a. Shoreline HABs are only partly resolved because of the mixed pixel problem between water and shoreline. And we also have a problem with shallow lakes and very clear lakes, where we're not really sensing water so much as viewing the bottom of the lake. So our project objectives was to come up with the best satellite index, build a model for New York lakes, and then evaluate it. Was it objective? Was it representative? Could we see eutrophication? And does it correlate with HAB impacts? The satellite system we decided to go with was Sentinel-2 from the European Space Agency. 2 satellites were originally launched. A third has just been launched in September 2024, so that is going to be an ongoing satellite system. Pixel size is 10 meters, so that's relatively high definition for water sensing satellites. 5-day revisit time. The method we're using is well established. We take satellite imagery, we do some processing of it to clear out the effects of the atmosphere, and we then compare that with in situ observations and laboratory analyses of, for instance, total phosphorus, chlorophyll, and phycocyanin. We match those observations temporally and spatially, and then use some of the resulting data set for testing and some of it for training. The training data, we arrive at an empirical relationship, and then we take that empirical relationship and apply it to new imagery to come up with an estimated value across lakes. You can read about our project in this publication, but basically we decided, for instance, for phycocyanin to use the maximum peak height algorithm, which combines a series of different bands. The R² for that relationship was pretty good, approaching 0.8, and this is the equation for the relationship. We can then apply that across a lake and over time. The way we do that is look at every pixel that represents the surface of a lake, process it so that we get the phycocyanin or chlorophyll-a concentration over time in that lake, and we can then summarize all of those concentrations into, for instance, a lake median phycocyanin concentration. Trying to do that with ArcGIS or another desktop GIS system would be complicated, so we've gone with these petabyte scale Earth systems, and NASA has one, Microsoft has their planetary computer, and Google has their Earth engine, which is what we're using. They have various pros. They're fast, they have distributed computing, multiple data sets are very easily accessible, no downloading, which is one of the best things, but they are complex and computer programming is essential. So verifying the programming, which took me several months to do, we are now able to image our lakes with estimated concentrations of phycocyanin and chlorophyll. We can go down to very small lakes. You can see that Mullen Pond here is 100 meters across. And in some of our lakes, we can see patchiness. We can see the distribution of higher concentrations, for instance, on lee shores in Lake Tahoe and Perch Pond. And we can also see variation of concentrations of pigments from year to year. So this is Chautauqua Lake down in the southwest of New York. And you can see that we have a north and a south basin. The south basin is often much higher concentration of phycocyanin, but some years are significantly worse than others. So that was verification. What about validation? Do our results represent reality? Well, in terms of distribution, we are using the same data set of regulated lakes as a shapefile to process our satellite imagery. So that it's a one-to-one match, it's fully matched, and it's not a sample, it's the whole population of regulated lakes. Now looking at phycocyanin, down here on the bottom, it's the estimated satellite phycocyanin, and on the y-axis is the median lake in situ phycocyanin. And we've got a relatively good R-squared value. We've excluded poorly sampled lakes and using only samples from September and October, the peak bloom season. Once we overlay the rest of the satellite data set on, we can see that we've got many more lakes that we can test out and screen based on that relationship. And quantity has a quality all of its own. The satellite limit of detection is around 8 micrograms per litre. We tried to do the same thing with chlorophyll and we got a very poor R-squared value. And then I noticed that we have these 6 lakes. I investigated each of them and found that the shapefile includes areas of macrophytes, duckweed, shallow water, and probably reeds. So once we took those suspect lakes out, we got a much better R-squared. But interestingly, over the whole data set of 2,000 plus lakes, we do see a bias towards high chlorophyll in smaller water bodies. That could be an artifact of the mixed pixel problem, or it could be that smaller water bodies do trend towards eutrophication. We then tried looking to validate our data set against the 303D list of lakes that are impaired for total phosphorus. In New York State, there's 117 of these lakes. And just to remind you that there's not a direct connection between HABs, phycocyanin, and phosphorus. But once we thresholded our satellite data set above 25 micrograms per litre, which is a common bloom threshold value, and compared those two data sets, we found that going back to your grade school, your Venn diagrams, there was an overlap of those two data sets. About 46 of those 117 lakes impaired for phosphorus also had high phycocyanin. Now, what about harmful algae bloom reports? Well, Seneca Lake at the beginning of September 2024, Seneca Lake is one of the Finger Lakes in central New York. We had a number of reports all the way around the lake. Many of these were shoreline blooms, no more than a couple of feet across, but Sentinel-2 true color imagery showed that there were appreciable blooms in the center of the lake in the northern part. And my colleague Alexi Davis also went up in a plane and coincidentally took a picture of the blooms. And then our study was able to estimate the phycocyanin concentrations in the bloom at greater than 50 micrograms per litre in the northern part. So that was gratifying validation. That was just one lake though. What about trying to compare all of the lake reports that we can get? I'm just using lake reports from 2023. We had HABs on 200 lakes, but that included small and large localized blooms, which might not be picked up by the satellite. So instead, I've concentrated on the lake-wide bloom reports, of which there were 79 lakes. Now, using that same threshold of 25 micrograms per litre, we found that of the 315 with greater than 25 micrograms per litre, 33 of them were also subject to lake-wide blooms. Now that is quite a low percentage. So we reversed this, and instead we looked at those lake-wide blooms and saw which of those blooms had satellite imagery exactly on that day. And 26 of the 79 lakes had at least one cloud-free image on a day a bloom was reported. And the others had either cloudy imagery or no images on the day of the bloom. I'm pleased to say that most of those blooms, lake-wide blooms with imagery, were confirmed as lake-wide, but there were interesting ones where it was clear that the center of the lake, despite being reported as lake-wide, was actually clear of phycocyanin. And so this can be quite a useful tool. So our conclusions are that Sentinel-2 is definitely usable and suitable for regulated lakes in New York State. We've used a quality assurance controlled local data set for a best local fit across New York State lakes, although we think that it could potentially be extended somewhat into the Northeast. We're using cloud computing solutions to enable this analysis. Lake-wide HABs can be confirmed at times if we're lucky with the imagery, and the satellite estimated pigment concentrations may provide supplemental indicators for screening 303D lakes. So in order to improve this work, we'd like to get better chlorophyll and phycocyanin estimates. The machine learning work has already started on that. We're going to extend our testing data set to later water quality data sets and Adirondack specific water quality data sets, which often have more highly colored and brown water. We could consider extending the temporal resolution back a couple of decades using a Landsat Sentinel-2 harmonized data set, and we would consider using a slightly different lake shapefile which would take into account bathymetry and mask out shallow or weedy areas. So we would love to use this technique to screen for HAB affected lakes and aid in lake assessment, but one of the biggest challenges, as I'm sure many of you would know, is to fit this into a regulated civil service workflow. And with that, I thank you for your patience and attendance.